This is chemistry, continuing our unit on dilutions. In order to save space in a laboratory, chemists will generally buy concentrated solutions. These are known as stock solutions. When we want a particular concentration of a solution, water is added to the concentrated solution in order to reach the desired concentration. So for example, common concentrations of concentrated acids are sulfuric acid, H2SO4 is 18 molar, nitric acid, HNO3 is 16 molar, and hydrochloric acid, HCl, is 12.5 molar. So here are images of each of these stock solutions. I know that they look like water, but they're not. These are very dangerous chemicals. If they were to get on your skin or in your eyes, they would cause a lot of damage. So this image is a basic setup for a dilution. So this is something that I would perform if I need a particular solution for one of your labs, right? So you can see the goggles, you can see the gloves. That large jug with that red cap, that's a stock solution of a particular acid. This large graduated cylinder would be for the water that I need for my dilution. And then this new container, this plastic jug, is where I would put my diluted acid. And then you can see that little sign in the background. If you actually go on in science and are possibly a lab assistant for some professor, you might be making solutions like this, right? So a rule you need to remember when making this dilution is that you always add acid to water. So as you pour the acid into the water immediately dilutes it. If you were to reverse that, there might be a little bit of a reaction, you might get some bubbling, and that might get onto your skin or in your eyes. So always put the acid into the water because it immediately starts to dilute as it goes into that water. Okay, so the process of adding more solvent to a concentrated solution is called dilution. A dilution problem typically involves determining how much water must be added to an amount of stock solution to obtain a solution of the desired concentration. There are two things to remember about dilution. The number of moles of stock solution does not change. Only a solvent is added in the dilution, typically water. So these two things just keep in mind. The number of moles does not change, and only a solvent is added, which is usually water. Now, in order to perform the calculation, the number of moles needs to be solved for since it will remain the same. So what am I talking about? Where's this coming from? Well, we did learn about molarity, right? And molarity is mole per liter, which is essentially mole per volume. So if we know that the moles is going to stay the same, we need to rearrange this formula so that it's solved for mole. All right, so mole equals molarity times volume. This number of moles that is desired does not change. That's why we solved for it. Okay, so if we want the final amount and concentration of a solution to be a certain value, we refer to these as M2 and V2. So M2 is the molarity after the dilution. V2 is the volume after the dilution. If we have the initial concentration and amount of the stock solution at a certain value, right, stock solution, right, that's where we're starting, that's our M1, which is the molarity before the dilution, and our V1, the volume before the dilution. So if M1V1 equals moles of solute and M2V2 equals moles of solute, they're both solved for moles, right? We can put them together in one equation. So it's M1V1 equals M2V2. This is what we're going to use in our dilution problems. And now we're going to practice two examples. All right, so let's try our first example. So it's asking what volume of 16 molar sulfuric acid must be used to prepare 1.5 liters of 0.1 molar sulfuric acid. Here's my sulfuric acid again. Okay, so we know the equation is M1V1 equals M2V2. So what does this mean from the information provided to you? Well, that's 16 molar sulfuric acid. Usually when you see a high number like that, that's your stock solution. So that's my M1 over here. And what's being asked of you is how much of that 16 molar sulfuric acid do you need in order to get this dilution that you would need for some particular lab. So let's say a lab called for 0.10 molar sulfuric acid, and you needed 1.5 liters of that for your classes. So that 1.5 liter and that 0.10 molarity, that's what's needed after the dilution. So that's the M2 and V2. So let's plug this in now. So the 16 molar, that's my stock solution of sulfuric acid, and I'm trying to figure out how much of that do I need for this dilution. So now what is the dilution? I want 0.10 molar sulfuric acid, so much safer to use, and then I need 1.5 liters of that for my classes. So let's just perform the math. So the first thing you need to do is multiply these two numbers. So we have 16 molar on the left, right, times V1, that doesn't change, this is what I'm looking for, but on the right, it's 0.10 times 1.5. Now, when I put this here, this is not milliliter, this is molarity and liter, right? Those are my units, and I just put them there so that you understand how this cancels. Now, to get V1 by itself, I'm going to divide, right, on each side by 16 molar. So now I just wanted you to see that the m's from molarity will cancel because I'm looking for volume, which is solved in liter. So now you take 0.15 divided by 16, and you should keep your significant figures. This shouldn't be too hard to figure out. Each value has two significant figures, so should my answer. So these leading zeros, that 0.00, right, those do not count. So the 9 and the 4 are your significant figures. There's two of them. And now just to help you understand what this is actually talking about, this 16 molar, right, that very concentrated stock solution, you don't need a lot of that, right? You only need 0.0094 liters of that to bring that concentration all the way down to 0.1. Okay, so a lot of water is going to be added, right, to get my 1.5 liters, but I don't need a lot of that stock solution. Okay, so that's what it's talking about. Now let's try one more. Right? Calculate the new molarity when 25.2 milliliters of 14.9 molar nitric acid is diluted to 1.00 liter. So now, what do we have? Okay, well, there's my nitric acid. You'll see it being revealed. Okay, same formula. M1V1 equals M2V2. So again, usually when you see that high number, that's your stock solution. So 14.9 molar nitric acid, that's my M1, that's the stock solution. And this time it's actually giving me how much of that I need, 25.2 milliliter. So that's my V1. I'm trying to dilute this now. So for a lab, right, I need 1.00 liters. And after performing this dilution, what is that new concentration? So it's going to be a safer concentration, very diluted, but what actually is it by the numbers? So let's plug this in now. Okay, 14.9 molar, right? That's my stock solution, but notice my volume, right? We need to continue to work in liters. So if you're provided with milliliter, you need to convert that to liters. So that's 0.0252 liter. So that's my stock solution, how much of it I need. I'm looking for what this becomes after this dilution, so how strong or weak is it? And then I need 1.00 liters of that for a lab. So the math remains the same, right? You multiply on the left, 14.9 times 0.0252 liter. M and L, that's not milliliter, that's molarity times liter. And I'm keeping my significant figures, right? 3 here and 3 here. And then this side does not change. Now I'm trying to get M2 by itself, that's my new molarity. So this is a nice calculation. So you're just dividing it by 1. But I put this up here so that you could see how the units cancel out. So liter and liter cancels because I'm looking for molarity. And notice I do put the M next to the number. I know it equals M2, right? And you see that M there, but you need to keep that unit next to the 0.357. So what does this actually mean now? So you have a stock solution and how much of it you need for the dilution. And now after it's diluted, you're going to have a liter of 0.357 molarity. So that's much, much safer for students to use.